Tutor PVSC here. Welcome to Phi 1000 Introduction to Physics. First year, by the way. The system is released from rest. How fast is the frictionless wheel with the momentum? Usually we call it the moment of inertia. Yeah. That and the radius that turning after 520 grams mass has fallen 2 meters. How long does it take the mass to drop this far? We are going to do this the easiest way. There are only 3 equations that you want to help you solve this problem. Step 1, we know that this mass is going down. So let's call it mass 2. So that is a weight, all right? Even here, the weight is moving down. Weight will always move down. Let's call this one mass 1. All right. Then remember that there's tension here going up. There's also tension here going up. So we've got tension number 2 here, and we've got tension number 1 there. Then at the same time, the wheel is turning and has got this information. So the radius of the wheel from there to there is just 7 centimeters, and the I is 0.005 kg square meter. That is what we have. All right, that is what we have. So based on the information that we have, I think everything has been indicated here. M2 is this one. We just need to convert this one into kilograms. Converting this one into kilograms, what do we get? I'm getting 0.5. Yeah, to just divide by the 1,000, by the way. Just divide by the 1,000. And here we are getting 0.500 kilograms. So this is your mass 1 and this is your mass 2. We have the information clearly labeled, right? All what we need to do is that now for the wheel being given this information, it means we need to apply the issue of torque. And I don't know if you remember torque, but torque, it has got something to do with work, all right, and energy as well as momentum. And if I get mass 1, okay, if I get mass 1, so if I get mass 1 itself, the forces acting for mass 1, you will discover that this force, because the wheel is going, this side is going down, this side is going up, so we have the tension pulling the weight upwards. So the tension is bigger than the force of gravity. This is equal to mass and acceleration. You do remember this formula? Summation of forces is equal to mass times acceleration. So these are forces, mass times acceleration. Mass number 2, we have the same, but this time around the tension is smaller than the weight, because the weight is pulling down. So the weight is larger and the tension is smaller, and we have that. So this is our equation number 1. We have our equation number 2. Equation number 3 is going to come from the wheel, where now we are going to relate what the issue of torque, all right, and the moment of inertia as well as the radius. All right, so the torque, so for the wheel, because the wheel is turning, so it is going to experience some torque, which will be equal to the moment of inertia multiplied by the angular acceleration. Remember this, right? This is our equation number 3. So having these 3 equations, how do we put them together to work out our problem? All right, let's go. So let me first write this equation. Torque is we know, all right? So then the net torque now, the net torque will be equal to the torque coming from the other mass and the torque coming from the other mass, right? Now for the other mass, well, it will be the tension, okay, multiplied by the radius minus the tension 1 minus multiplied by the radius. Remember that the radius is the same. So as the rope moves, one mass moves clockwise, the other one moves anti-clockwise. It's normal like that. And because they are moving in anti-clockwise direction, this is the reason why we are subtracting them. Okay. And for the information here, we are saying this is just equal to moment of inertia multiplied by angular acceleration. But remember that acceleration itself is given by angular radius multiplied by angular acceleration. I think if you recall this one. All right. That means we need to make this the substitute formula, which will give us A over R. So if we substitute there, we are having T2R minus T1R is equal to I in brackets A over R. If I take out the R here, you discover that I will be multiplying both sides by R, even this side by R, giving me T2 minus T1 is just equal to I M over R squared. I need this. It's really important. And from here, you can see that what I've just written here is the net force, T2 minus T1, I R squared, then A, which corresponds to this equation. So the force is this first part. The mass is this part there. Then the acceleration at the end. So keep this equation number 4. You need it. So from equation 1, we know that T1 minus M1G is equal to M1A. If I make T1 the Shapley formula, I'm getting M1A plus M1G. From equation number 2, I know, so if I swap them, I'm having T2 is equal to M2A. Sorry, I'm having M2G minus M2A. Yes, like that. So these equations, they are going to help us. Now that we have this friend of ours, we need to make substitutions now. Okay. Where are we substituting this? We are taking them into this equation there. We know what T2 is. T2 is mg2 minus m2a. Then have minus m1a plus m1g. Understand this is equal to this squared a. All right, so we need to make a the subject of the formula, which is the acceleration. All right, I think from here is quite easy. That means a equals to all right, well, we can solve together. It's fine. Okay, so we get up m2g minus m2a minus m1a minus m1g is equal to that over r squared. We've got a there, and well, I can group all the m1s together, or I can say I can group everything to do with g, so I can get m2 minus m1. This I've got g. Then yes, this I've got g. Then I'll say plus these two I've got a. So that will be minus m2 minus m1, then a is equal to I r squared, then a, like that. It's making sense, right? Then I think from here everything is done, because if I remove negative here, this becomes m2 minus m1 minus m2 minus m1. Sorry, this becomes plus now, plus a is I r squared a. If I make a the subject formula, I discover that a will be equal to this will be the denominator, which is m2 minus m1 multiplied by g. Oh, there's a g here, by the way. Then we've got m2 plus m1 again plus this one here. It will join them like that. This is how we can find the acceleration. But you might wonder, why are you finding acceleration? Well, you'll see. We can now plug in everything now. m1, m2, 0.52, 0.50, we know that, right? 0.52, 0.50, multiply by what? Gravity, we can use 9.8. Yeah, I think, yeah, that's all. Oh, sorry, you have plus I is 0.005 over radius. Remember, this is 7 centimeters. We can convert it to meters to give us 0.07. So 0.07, and we have to square it like that. All right, get your calculators ready. All right, so it is subtracting this, so I think you just get 0.02. Then multiply this one by 9.8. over adding those, I think I'll get 1.0 to myself. All right, so 0.005. Let's square 0.07 because there's a 7 there. I am lucky to get 49. Now 2 zeros being squared, 0.00049. All right, so okay, where do we go? Get your calculators, please. Let's punch this together. All right, so punching myself, I'm getting 0.196 over down there. What we get? 1.02, 0.05 over 0.0049. I'm getting 2.0404 like that. And dividing everything together, I'm getting 0.096 meters per second squared as the acceleration. But you might wonder, we haven't even started answering part 1 now. Let's go to part 1. We know that we need to find velocity on part 1. Anytime they ask you how fast something's moving is velocity. All right. Now, in this case, what is moving? It is the wheel. So the wheel is going to experience angular velocity. All right. But we know that for us to find angular velocity, there is a relationship between velocity and angular velocity. This is the relationship. So for us to find this friend of ours, we need to know what this one is. Don't you think? Okay. But from this equation of motion, okay, we know how to do that. Remember, this friend of ours, it has fallen 2 meters below. That is the height or the distance S. So from here, and recall, it was coming from rest, so initial velocity is what? 0. That means even initial angular velocity is also 0 from rest. So if I put them there together, okay, so I'll just end up having this squared is equal to 2as because this is 0. So v is equal to the square root of 2. Now in this case, we're saying g, h because acceleration is, sorry, a, s. So it's 2, acceleration, we just found it, it's there, 0.096, 0.096, and distance is 2 meters. So we find the square root of that. Okay. So I'm getting 0.6, let me just say 0.62 meters per second. Now that I know what this velocity, I can now forward and say this over that. Have I done the correct substitution? Because yes, it's fine. So 0.60 when we divide by the radius is 0.07. Guys, it is 7 centimeters. So let's divide those. I'm getting 8.85 rad per second. But when we look at what we've been given, it's 8.05. What is the problem? The problem is the correct inertia, moment of inertia, it was supposed to have 3 zeros here. So it was supposed to be 0.0005, not 0.00. So in our case, being given the incorrect moment of inertia, we found our correct answer. That. B is asking about what? B is asking about how long does it take the mass to drop. Because of that, even the time here to be different. Okay? Are we together, right? So to find the time shouldn't be that difficult. You know this equation of motion, right? You know it. This is 0, so this goes to at. So t is equal to what? V over a. So v is 0.62 over. We just found it there. Acceleration, we found it too. I think if I recall properly, it was 0.09. 6. Okay, yeah. Dividing this, I'm getting 6.45 seconds. You see, it's also different from what we've been given because we have the incorrect moment of inertia. Nevertheless, follow these steps, you'll be fine.